Well, welcome to statistics number 30. It's more normal distributions. It's probably normal 8 or so. Anyway, statistics 30. This is going to be about more inverse normal problems. And as I said in class, we're going to work on problems like area to the right and area in between. And so we're going to want to talk about those things right now. And I have a couple of problems for you. And with these problems, we're going to do these two examples as examples of what we need to do. And so without much further ado, we're going to proceed forward. I'm going to do it by shrinking these so you can see it. So first of all, I have an area to the right problem. And that area to the right problem involves quite a bit of area to the right, a little over 10%. And as we said in class, this involves us really, what we're trying to do is find the z value that gives us that area to the right. Well, we can find that z value just as well by finding the area to the left. So what we want to do is take 1 minus 0.1076, which will give us 0.8924, and that 0.8924 represents the area to the left right here. And since we have that area, we can now just go to our table and find that z-score that corresponds to this area. And I'm going to whip over to my table really quickly and find that z-score. We need to remember when looking for z-scores that the exact number might not show up. And so my closest numbers is 0.8925, which is really, really close. And on my table, that gives me a z value of 1.24 standard deviations. So my z is equal to 1.24. And so that's all I need to do for area to the right. Now in area in between, a different thing is happening. We are going to focus on trying to find two z values, but it turns out one of them is z and the other is negative z. In other words, they're opposites of each other. And the reason why this is important is it tells us that these two z values on the number line here are equally spaced about the mean, which in our case, since we're in the standard normal, is 0. And since they're equally spaced, we can figure it out. That means we can divide whatever probability we were given, we can divide that in half. So I can take 0.7200 and divide it by 2 and get 0.3600. And then that 0.36 represents this area right here and this area right there. And so what I want to do then is I need to recognize that at 0 standard deviations, the probability is equal to 0.5. So what I need to do is take 0.5000 and subtract 0.36. And that will give me 0.1400. And this is the number I need to look up in the table. What's the 0.1400 represent? Well, it represents this part of the graph. It represents the area to the left right there. So if I go look up 0.1400, as my probability. I'm on the negative z-scores in 0.1400. My closest one is 0.1401, so I'll use that. And it gives me a z equal to negative 1.08. All right? Therefore, the other z has to be equal to 1.08. So by finding this area to the left over here, you can use that, and that you'll find the negative z, and then you can find the positive one. So I'll write this as negative z. This is negative 1.08. Okay? And I hope that helps you to see how we do this kind of problem. It's always making sure that we know the area to the left. Now, can we do in between areas where these are off, where they're not opposites of each other? And the answer is, with our table, the answer is no, we can't do that. And so your job tomorrow is going to be doing problems exactly like these. So let's do another example or two, and then we'll let you go. So here are two quick problems that we would like to do. And the first one you can see is find the z-score with 85% of the area to the right. And the second one is the z-score with 85% of the area between z and negative z. So what I always do is I draw a picture. So 85% of the area to the right would look something like this picture, and 85% of the area in between c and negative z would look like this picture. And so that gives us both our pictures, and what we'd like to do is we'd like to be able to solve those. So again, the white one, that means what I need to know is I need to know this area right there to the left of that, and all I do is I do 1 minus 0.85 and I get 0.15. And what that means is now I could either look that up in the table, or I can use the inverse normal statement, which says take the area to the left, take the mean and the standard deviation, and it'll calculate that for me exactly. On the next one, in that case, since 85% is in between, what I am going to do is I'm going to divide that 85% in half, right? That means the area in half of it is 42.5% of the area. So I took 85 divided by 2 and got 42.5. And then I take 1 minus 0.4250, or excuse me, 0.5 minus that, because I'm only on half of this, and that gives me 0.0750, and that is going to be the area to the left, also to the right. But that's the area to the left, so I would look this up on a table. Or, if you wish, I can use the inverse normal and do 0.075, comma 0, comma 1, and that'll give me the z-score. So once you do those immediately when you come to class and see if you get an answer. So your job tomorrow is to come to class, grab a graphics calculator, and do these two problems. Okay, that's all for now. We'll talk to you later. Bye.